Hi everybody, going to try and make this quick video here. Okay, it's on this one, number 14. It says two concentric current loops lie in the same plane. The smaller loop has a radius of 3 centimeters. So smaller loop has a radius of 3 centimeters, current of 12 amps. The bigger loop has a current of 20 amps and a magnetic field of the loops. The magnetic field at the center of the loops is found to be 0. So magnetic field at the center is 0. What is the radius of the bigger loop? So I'm trying to find the radius, okay, of the bigger loop. So I already started by drawing a diagram here of kind of what they're doing. So I got two loops here. The smaller loop has a radius of 3 centimeters. The bigger loop, that's the radius that I'm looking for. So there's my two loops. The current going through the smaller loop is 12 amps. The current going through the bigger loop is 20 amps. And I know my magnetic field at the center is going to be 0. So just to kind of show you what this looks like, if I were to look at the thing here, such that my vision was something like this, what I would basically see is like a loop here and a loop here. These are like the ring parts right here, where the current is going in here. Right, this is IB here, and the current's going out here. That's IB. And then I have a smaller loop, so I'm looking at it from the side, where the current is going out here. So this is the current from the small loop. So this is the current from the small loop. And so if I use my right-hand rule, I can see the current from B is going to produce a magnetic field at the center going this way. And B meaning the big loop. And then the current from S, I think, is going to produce the other way. So that's going into the page. So it's out of the page for current B, into the page for the magnetic field for the small current. So there's that. And basically I know these have to add up to 0. So basically they need to, so B net equals 0, or BB minus BS equals, or I could say BS is pointing to the right, so it's positive, this is negative, equals 0. Regardless, the magnetic field for the small one is going to equal the magnetic field for the big one. It's a loop. So if you look up your equations, it's mu naught over I, so it'd be IS over 2RS. And this is going to be mu naught IB over 2RB. So again, what's nice is mu naught and 2 cancels out. Now I just need to isolate, what am I trying to find? The radius, the big radius. So I'm going to just isolate for the big radius right here. So there's a bit of algebra here. But I'm going to get IB over IS and then multiply by RS. So if I plug in everything now, I'm going to get IB, that's 20, divided by IS, which is 12. Multiply by the small radius. I'll keep it in centimeters, so I'll get my answer in centimeters. So 3 centimeters. So RB then is going to be, and if I calculate this out, 20 divided by 12 times 3. And I get about 5 centimeters. All right, hope that helped. Bye.